Hi there, this is your video on recursive rules for sequences. You're just going to need to take notes on loose leaf paper while you're watching the video. Okay, so let's review really quick. The explicit rule is what you learned on the last video and in our last class. An explicit rule is a function based on a term's position, which we call n, in a sequence. All the rules for the nth term that we've been working on with are explicit rules, such as, here's your arithmetic explicit rule, so any term a sub n is equal to the first term, a sub 1, plus n minus 1 times the common difference. Or your geometric sequence, which has an explicit rule of a sub n, any term, equals a sub 1, the first term, times the common ratio with a power of n minus 1. Hopefully you feel comfortable with those by now. A recursive rule is when we relate a term to its previous term. And when we relate a term to its previous term, we're going to use a sub n minus 1 to represent the previous term. Think of that as a variable. Now, in a recursive rule, you're going to give the first term of the sequence. Because we're relating everything to its previous term, we need to know what the first term is. And then we need to give an equation that relates the given terms to the next terms in the sequence. So that's where the previous term is going to come into play. Okay, so any term is a sub n. The previous term is a sub n minus 1. For example, if we're given a sub 0 equals 1 and a sub n equals a sub n minus 1 minus 2, the first 5 terms of the sequence would be a sub 0, a sub 1, a sub 2, a sub 3, a sub 4. Now in this case, because they started here with a sub 0, that's why we're starting here with a sub 0. If they started with a sub 1, that's what we would start with. Now, each of these terms is determined above. So a sub 0 is 1, so our first term is 1. This is telling us that any term in the sequence is equal to the previous term minus 2. So this is why we need to know the first term to get the next term. So if a sub 0 is 1, we're going to subtract 2 to get the next term. And that gives us the pattern to follow throughout the entire sequence. So if I take 1 as my first term and subtract 2, I get negative 1. And then I subtract 2 from that and I get negative 3, subtract 2 as negative 5, subtract 2 as negative 7. And there is your sequence. Okay, so this rule is actually a little bit easier to understand because this right here is telling you what to do for each term. All right, so here's an example. We're going to write the first 5 terms of the sequence, and this is just going, but that's okay. Take a look. A sub 1 is 2. A sub n is a sub n minus 1 plus 4. So here's what we need to know. Here's our first term. That's a sub 1. There's our first term. Then the plus 4 tells us to take the previous number and add 4. Okay, so a sub 1 is 2. A sub 2 is the previous term a sub 1 plus 4. Okay, the previous term was 2, so we do 2 plus 4 to get 6. A sub 3 is the previous term a sub 2 plus 4. The previous answer was 6, so we do 6 plus 4 to get 10. And so on and so forth. We're just taking the previous answer and adding 4. So a sub 4 is the previous answer of 10 plus 4, and a sub 5 is the previous answer of 14 plus 4. And so our sequence is 2, 6, 10, 14, 18. You can see we're adding 4 along the way. Now, with a recursive formula, we cannot get to, let's say, the 50th term without knowing the 49th term. And we can't do the 49th term without knowing the 48th term. So the only way with a recursive formula to get to the 50th term is to know all of the terms from 1 through 50. So that's the disadvantage to this. But we can take this sequence, we found the first 5 terms, and write it as an explicit formula that can then help us. 2 is our first term. We're adding 4, so our common difference is 4, and we're going to plug those two things into our explicit formula from last class. So a sub n equals a sub 1 plus n minus 1 times d. So a sub 1 equals first term was 2, okay, plus n minus 1, that always stays, times the common difference, which is 4. Then we just clean this up, so we're going to distribute the 4, and then combine like terms, and we're going to get a sub n equals 4n minus 2. Now you can find the 50th term just by plugging in 50, or the 100th term just by plugging in 100. So if you have a recursive formula, you want to find the first 5 terms or so, and then once you get the hang of that, you can figure out the explicit formula. Okay, look at these two formulas together. Our recursive formula was a sub 1 equals 2, and a sub n equals a sub n minus 1 plus 4. Our explicit formula was a sub n equals 4n minus 2. The only thing that these two things have in common is that the common difference will be located as a plus or a minus here, and what appears to be the slope of the line here. Okay, those are the only things that those two have in common. It's a coincidence that there's 2's in both of them. Okay. Now we're going to take the indicated rule for the arithmetic sequence with a sub 1 equals 15 and d equals 5, and we're going to do explicit and recursive. So the explicit formula, plug in a sub 1 and plug in d, distribute and combine like terms to have an explicit formula of a sub n equals 10 plus 5n. Okay, or 5n plus 10 would be fine. So we had our first term and our common difference, and there we go. For the recursive rule, the first term is necessary to the rule. Okay, oh, there's the answer. So we need to figure out that the common difference of adding 5 is going to help us with our recursive formula. So any term, a sub n, is equal to the previous term, a sub n minus 1 plus 5. So notice that these two parts are always the same. You just put over here what you're adding or subtracting or even multiplying, which you'll see in a minute. Okay, now the recursive rule has to start with a sub 1. So the recursive rule would be a sub 1 equals 15, comma, a sub n equals a sub n minus 1 plus 5. So the recursive rule requires the first term and the formula to get to the next term, whereas our explicit formula was all based on n and we didn't need more information than that. Okay, now we have a geometric sequence with a sub 1 equals 4 and r is equal to 0.2. Your explicit rule, like we did last class, just plug the numbers in. So we have 4 times 0.2 to the n minus 1, and there's your explicit rule for the geometric sequence. Remember, it should look like an exponential function, and it does because the variable is in the exponent. The recursive rule uses the idea that to get to the next term, you multiply the previous term by 0.2. So any term a sub n is equal to r, the common ratio, times a sub n minus 1. So in this case, 0.2 times a sub n minus 1. Again, remember we do have to state the first term. So our recursive rule would be a sub 1 equals 4 and a sub n equals 0.2 times a sub n minus 1. Okay, and there's your two rules, explicit and recursive. And lastly, we're going to write a recursive rule for the sequence 1, 5, 25, 1, 25. So first question is the sequence arithmetic, geometric, or neither? Are we adding? Are we multiplying? Or nothing? In this case, we're multiplying. Okay, so it's geometric. Let's find the pattern. Multiply the previous term by 5. Okay, now because we're writing the recursive rule, we're interested in what we do to the previous term. The first term is 1. So the recursive rule would be a sub 1 equals 1 and a sub n equals 5 times a sub n minus 1. Okay, so again, we have an a sub n and an a sub n minus 1 always, and then we just indicate what we're doing there, which in this case is multiplying by 5. You can put the times 5 at the end as well. And there is your recursive rule. Okay, I hope this was helpful, and I hope you took good notes on loose leaf, and I will see you in class.